Let's now look at some string functions, that is, functions for working with strings, in the tidyverse. All the tidyverse string functions begin with str underscore to keep them consistent. Here's how to check string length. str underscore length. So I'm going to check the length of string 7. And it's 45. Here's how we combine strings. str underscore c. So here I'm going to combine A, B, and C. And you can see what we end up with is one string that has A, B, and C in it. You can combine strings and separate them with a character of your choice. So on line 66, I'm combining A, B, and C, but separating with a comma. And you can see here in the console window what happened. On line 67, I'm going to separate with a space. And here's what happened. Here I'm going to use the writelines command. Remember that the writelines command in R is how we actually see how something will be printed out in the console, or if we output it to a printer on a printer. So here we're going to combine strings 5, 6, and 7, but we're going to separate them with the \n. So I'm using the string C command within the writelines command in order to separate these strings with a new line. Remember that one of these strings itself had new lines built into it. Actually, two of them did. So here's the first string. The second string is actually these 3 lines here, and then the third string had new lines and tabs. Let's try this again with a character vector. So I'm going to create a vector. Here's the vector, A, B, and C. And now I'm going to use string C on my vector. What happened? This happens because str underscore C, the string concatenate function, is vectorized. So therefore, the function is operating on each individual element of the vector. We can override this by pulling out each element of the vector. So notice what I'm doing here now. I'm taking the vector, my vector, the first element, the second element, and the third. And therefore, I'm operating on the elements of the vector instead of treating this as a total vector. So because it's a vectorized function, concatenating on a vector is not going to combine within the vector. So what we're doing now is we're pulling out within the vector and then concatenating. And there you go. Alternatively, we can collapse a vector of strings into a single string. We can do that using the collapse argument. So remember what my vector looks like this, over here in the console window, A, B, and C. So now what I'm going to do is I am going to collapse, and notice all I'm having here is the double quotes. Let's see what happens with that. There you get A, B, and C. So that single vector that had 3 different elements is collapsed into a single string. We could use different kinds of separators. So notice what will happen when I collapse my vector with comma. Now I'm collapsing, but I'm putting commas between. On line 86, I collapsed with nothing between. That's what it meant to have the quotes back to back. We can use the vectorization aspect of the string concatenate function to do some interesting things. Now take a look at this and think carefully about them. Once again, I'm going to put my dot vector up here to remind you what it is. You can also see it down here in the environment window. It's right down here. Okay. Here we go. It's A, B, and C in quotes. So look what happens here. String C, my vector, and then I'm putting 1. So because this is vectorized, each element of the vector now receives a 1. So we have A1, B1, C1. Check this out, where I'm using string C and then a vertical line on each side. Here's what happens if you have missing data. So now I'm going to create vector 2, and let's look at it. I called it my vector 2. There we go. So we have A, missing data, B. Notice miss NA is not in quotes. That would make it the string NA rather than missing data. All right, let's use those double lines. So here is our first, here's our missing data, and here is our third. If you want to treat NA as the string NA, you can do it by using the string replace NA function. So here, notice what happens on line 105. Now we replaced any NA in my dot vector 2 with a string. So it made it, instead of NA, it made it NA in quotes. And therefore, when we did the concatenation with the vertical lines, it added those vertical lines to them. If a string has no length, it is dropped. So notice here, 0 is the length of this string where we just put quotes with nothing in it. So let's concatenate. My name is space, then I have nothing, no length, and then Mike. And therefore, when I concatenate this, that string of no length, which is treated as nothing, is dropped, and we end up with my name is Mike. This feature actually has some uses. It's especially useful with the if function. So let's try this. My name is going to be assigned Mike. Time of day is going to be assigned afternoon. Birthday is going to be assigned false. So here's what this string says. Concatenate good and time of day. Okay, so remember time of day is afternoon, so that's good afternoon. And then we're going to have a space. Then we're going to have my name, Mike, and then it's if birthday. So in other words, if birthday is true, then we say good afternoon, Mike, and happy birthday. But it was not true. It was not my birthday. So if I had been doing this on April 9, I could have set birthday equal to be true because it was my birthday. And then if I had set it equal to true, then it would have said, good afternoon, Mike, and happy birthday. So because this was false, this became just no string at all, and therefore it was dropped. And so I had the right setting, the right kind of printout, good afternoon, Mike, when birthday is false and the right kind of printout when birthday is true. Very useful concatenate function. So string underscore length checks the number of characters in a string, and string underscore C combines strings or concatenates them. In part 3, we'll look at some more string functions that are available to us in the tidyverse. I'll see you then.